A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. The most expensive part of your AI model isn't the GPU time or the electricity bill anymore. It is the human hours spent labeling data. We are talking about thousands of people sitting in rooms or at their kitchen tables, drawing boxes around stop signs, or ranking which AI poem is less cringeworthy.
It is a massive industry, Corn. As of April 26, the data annotation market is projected to hit $8.5 billion. Yet, if you look at most developer forums or even corporate AI strategies, annotation is treated like an afterthought. It is the janitorial work of data science that actually determines whether your model is a genius or a total disaster.
Well, if you feed a model garbage, you get garbage out. That is the oldest rule in the book. Today's prompt from Daniel is about demystifying this whole world of data annotation and the tools people are using to prepare these massive data sets. And honestly, Herman, I think people underappreciate how much human is still in the artificial intelligence.
It is almost entirely human at the foundational level. By the way, today's episode is powered by Google Gemini 3 Flash, which is fitting since we are talking about the very data that makes models like Gemini possible. I am Herman Poppleberry, and I have been digging into the latest benchmarks from the 25 and 26 reporting cycles on this.
And I am Corn. I am the one who asks why we are spending $8 billion to have people click on pictures of crosswalks. But seriously, let's frame this. When we say data annotation, we aren't just talking about tagging photos on social media. What is the actual technical scope here?
At its simplest, data annotation is the process of adding metadata labels, tags, or coordinates to raw data so a machine learning model can understand it. Raw data is just a soup of pixels or characters. Annotation provides the ground truth. If you want a model to recognize a tumor in an MRI, a human radiologist has to first sit down and color in exactly where that tumor is on 10,000 images. That colored in area is the annotation.
So it is basically teaching by example. But the examples have to be perfect. If the radiologist is tired and misses a millimeter, the AI learns that a millimeter of tumor is actually healthy tissue.
Precisely the danger, and it spans everything: text, image, audio, video. In 26, we have moved way beyond, is this a cat? We are now in the era of RLHF reinforcement learning from human feedback. This is where humans rank AI responses. They will look at two different answers from an LLM and say, answer A is more helpful, but answer B is more concise. That ranking is an annotation that tunes the model's behavior.
But how does that ranking actually translate into math for the model? If I say answer A is better, is the model just looking at a +1 in a spreadsheet?
Not exactly. It's more sophisticated. We use reward models. You take those human rankings and train a separate, smaller model to predict what a human would prefer. Then, you use that reward model to grade the main LLM during its training phase. It creates a feedback loop where the AI is constantly trying to maximize its human likability score.
It sounds tedious, but I guess it is the only way to get nuance. Let's get into the weeds of how this actually happens. You mentioned ground truth, but how do we ensure that truth is actually true? If I hire 10 people to label sarcastic tweets, I am going to get 10 different opinions.
That brings us to the first big technical hurdle: quality control and inter-annotator agreement, or IAA. In professional workflows, you don't just have one person label a data point, you have 3 or 5. Then you calculate a metric like Cohen's kappa.
Cohen's kappa sounds like a fraternity for statistics nerds.
It basically is. It is a robust statistic that measures the agreement between two raters, taking into account the possibility of the agreement occurring by chance. If your Cohen's kappa is 0.8 or higher, you are in great shape. If it is 0.4, your instructions are probably confusing, and your annotators are just guessing.
So, if I am a developer, I am looking at these scores to see if my data is even usable. What happens if the score is low? Do you just throw the data away?
You usually go back to the annotation guideline. This is a living document that defines the rules. For example, if you're labeling pedestrians, do you include people on skateboards? If the annotators are split 50-50, you have to update the guideline to say, yes, skateboards count as pedestrians, and then have them relabel. It's an iterative process of reducing ambiguity.
What about the actual physical acts of labeling? I see people talking about bounding boxes all the time. Is that still the standard?
Bounding boxes are the bread and butter for object detection. Think, draw a rectangle around every car in this frame. But for high-stakes stuff like autonomous driving or medical AI, we use semantic segmentation. That is, pixel-level labeling. You aren't just drawing a box around a car, you are coloring in every single pixel that belongs to the car. It is incredibly time-consuming. A single image for an autonomous vehicle dataset can take an hour for a human to annotate perfectly.
An hour for one image? No wonder the market is $8 billion. If you need 100,000 images, you are looking at a century of human labor. There has to be a way to speed that up.
There is, and this is where it gets cool. We use active learning loops. Instead of just handing a pile of 1,000,000 images to humans, the model itself gets involved. The model looks at the unlabeled data and says, I am 99% sure these 50,000 images are cars, so don't waste human time on them. But these 300 images? I have no idea what is going on here. Send these to the humans.
So the AI acts like a filter, only showing the humans the hard homework.
Right. Scale AI released a study in 25 showing that active learning can reduce total human labeling effort by 30 to 50% without losing any model accuracy. It identifies the edge cases, the weird lighting, the obscured objects, and focuses human intelligence where it matters most.
That makes a lot of sense. It is like a teacher focusing on the student who is struggling rather than the one who's already acing the test. But wait, if the model is choosing what it wants to learn, isn't there a risk of it creating a blind spot? Like if it doesn't know what it doesn't know?
That is the big risk of sampling bias. If your model is already biased, its uncertainty might lead it to ask for more of the same kind of data it already understands poorly, while ignoring a completely different category it hasn't even noticed. That is why you still need a gold set, a small, perfectly curated data set that acts as a yardstick to keep everything on track.
Okay, so we have the theory. We need humans, we need metrics like Cohen's kappa, and we need active learning to save our sanity. Let's talk tools. If I am starting a project today, am I just using Photoshop and a spreadsheet? Or is there a Word or Excel of data annotation?
There is a whole ecosystem now. It is really divided between enterprise platforms and open source tools. If you want the all-in-one powerhouse, you look at Labelbox or Scale AI. Labelbox is fascinating because they have moved toward what they call data-centric AI. Their platform isn't just a place to draw boxes, it is a full-blown workflow manager. It integrates directly with your model training pipeline.
I have seen Labelbox. It looks sleek, but I bet it isn't cheap. What is the draw there compared to something I can just download?
The draw is automation and scale. They have model-assisted labeling. The model takes a best guess at the label, and the human just nudges the corners of the box or hits confirm. This can cut costs by 70% because a human can verify a label much faster than they can create one from scratch.
It is like autocorrect for data labeling. You still have to watch it, but it does the heavy lifting. What about Scale AI? I hear their name every time someone mentions LLMs.
Scale is the heavy hitter for RLHF and autonomous vehicles. They are the ones who basically powered the data behind the big foundational models we use in 26. They specialize in that high-touch human feedback. If you need 5,000 PhDs to rank the factual accuracy of an AI's medical advice, Scale is who you call. They have the human cloud ready to go.
That is a wild concept. A human cloud. It sounds like something out of a sci-fi novel where people are just nodes in a giant computer.
In a way, they are, and the logistics are intense. Think about the gig economy, but for cognitive labor. Scale manages thousands of workers across the globe, ensuring they are trained on specific tasks. They use consensus mechanisms where the same image might be sent to 3 different people in 3 different time zones. If 2 say it's a stop sign and 1 says it's a yield sign, the system flags it for a senior reviewer.
It's like a digital assembly line where the product is certainty. But on the other side of the fence, you have the open source world. Label Studio is probably the most popular one there. It is highly customizable. If you are a developer and you have a very weird data format, say multispectral satellite imagery combined with audio logs, you can build a custom interface in Label Studio to handle it.
Massive. Think about healthcare or defense. You can't just upload patient records or classify drone footage to a random cloud provider's labeling tool. You need to keep it on-prem. That is where Label Studio or CVOT, the computer vision annotation tool, really shine. CVOT was originally developed by Intel, and it is the gold standard for video annotation. It has interpolation, which means if you label a car in frame 1 and frame 60, it can calculate the movement and automatically fill in the boxes for the 58 frames in between.
Wait, interpolation sounds like a lifesaver. Does it work even if the car moves behind a tree?
That's the tricky part. Most modern tools use re-identification algorithms. If the car disappears behind a tree and reappears, the tool tries to stitch those 2 paths together so the model knows it's the same physical object. Without that, the AI might think the first car vanished and a second, identical car was magically born on the other side of the oak tree.
Okay, so we have the expensive automated cloud stuff like Labelbox and Scale, and the do-it-yourself but powerful open source like Label Studio and CVA. But Herman, let's talk about the synthetic data elephant in the room. I keep hearing that we are going to stop using humans entirely because we can just have AI generate the training data for other AI. Is that actually happening in 26, or is it just hype?
It is happening, but it is not a total replacement. It is a supplement. NVIDIA has been a leader here with their synthetic data toolkits. Think about training a robot to work in a factory. Instead of filming a real factory for 10,000 hours, you build a hyper-realistic digital twin of the factory in a physics engine. You can generate millions of images of the robot failing or succeeding with perfect, pixel-perfect labels generated by the computer. No humans required.
Because the computer knows exactly where the virtual parts are, because it created them. That is genius. But does that work for text? Can an AI write human text to train another AI?
That is the model collapse problem we have discussed before. If you train an AI on too much AI-generated text, it starts to lose touch with reality. It becomes an echo chamber. For text and complex human reasoning, we still need that human in the loop. You can use synthetic data to bulk up a data set, but the gold set, the truth, still has to come from us.
So humans are the salt in the soup. You don't need a lot of it compared to the water, but without it, the whole thing is tasteless and useless.
That is a great way to put it. In fact, a major trend in 26 is data curation over data collection. We have realized that a small, perfectly labeled data set of 1,000 items often outperforms a messy, machine-labeled data set of 100,000 items. The industry is moving toward quality over quantity.
I love that. It feels more artisanal. Small batch, hand-labeled organic data.
Don't give the marketing departments any ideas, Corn. But seriously, if you are a startup, your goal shouldn't be get a billion images. It should be get 10,000 perfect images. And that requires a very specific workflow. You start with a pilot. You use an open source tool like Label Studio or CVAT. You label a few hundred items yourself to see where the ambiguities are.
Right, because you don't know what you don't know until you try to label it. You might realize that, is this a car? Is a hard question when you are looking at a truck or a van. Do those count? You have to define those rules before you hire people.
You create an annotation manual. It might be 50 pages long, detailing exactly how to handle shadows, reflections, and near-miss categories. Then you run a small group of annotators through it and check their Cohen's kappa score. If they are all over the place, your manual sucks. You fix the manual, then you scale.
What about the ethics of this? We are talking about billions of dollars, but the people actually doing the labeling, I have read reports that they aren't exactly getting rich.
It is a serious issue. A lot of this work is outsourced to regions with lower labor costs. In 26, we are seeing a push for ethical annotation. Tools like Super Annotate now include bias dashboards. They track the demographics of the annotators to ensure you aren't getting a purely Western-centric view on a global product. If all your helpful labels are coming from one specific culture, your AI is going to be biased toward that culture's values.
It is basically digital colonialism if you aren't careful. You are taking the subjective values of one group and hard-coding them into the truth for everyone else. Think about a politeness filter for an AI assistant. What's considered polite in New York might be considered rude in Tokyo.
And if your labeling team is entirely based in one of those cities, the model will inherit that local etiquette. This is why diversity in annotation is becoming a technical requirement, not just a social one. If you want a global model, you need a global labeling force.
And regulators are catching on. The AI acts that have rolled out globally now often require data lineage. You have to be able to prove where your data came from, who labeled it, and what the instructions were. You can't just have a black box of data anymore. You need an audit trail.
That sounds like a nightmare for developers who just want to move fast and break things. But I guess when you are breaking things with AI, the consequences are a bit higher than a broken website. Much higher. Think about medical AI. If a startup uses a tool like Ncord, which is specialized for medical and video AI, they are doing it because Ncord handles the DICOM image formats used in hospitals and has the security protocols to keep those images private. You can't just throw an X-ray into a generic labeling tool and hope for the best.
I'm curious about Ncord. Why is a specialized tool necessary for a medical image? Isn't an X-ray just another picture?
Not at all. A standard JPEG has 256 levels of brightness. A DICOM medical image can have over 65,000. A doctor needs to be able to adjust the contrast, what they call windowing, to see a tiny fracture that would be invisible in a normal photo. Ncord allows the annotator to do that windowing right inside the labeling interface. If you used a standard tool, the annotator might miss the very thing they are supposed to label.
So the tools are becoming specialized. Ncord for medical, CVAT for video, Scale for LLMs. It is not a one-size-fits-all world anymore.
Not at all. And the pricing models are shifting too. It used to be pay per label, which encouraged speed over quality. Now many platforms are moving towards seat-based or volume-based pricing with built-in quality audits. They want to align the incentives so that the annotators are incentivized to be accurate, not just fast.
That is a big shift. It is the difference between a factory line and a craft workshop. Let's talk about the practical takeaways for someone listening who is actually building a model. We have covered the tools and the theory. What does the Monday morning look like for a developer starting a dataset?
Step 1. Don't outsource yet. Label the first 100 items yourself. You will find that your data is much messier than you thought. You will find edge cases you never considered. Oh, the camera was blurry in this shot. Does it count as low visibilities or unusable?
Step 2. Pick a tool based on your data type, not just what's popular. If you are doing video, don't use a tool built for text. Use CVAT or Ncord. If you are doing LLM fine-tuning, you might even stay within the ecosystem of your model provider, like Amazon SageMaker Ground Truth if you are already on AWS.
Step 3. Implement Inter-Annotator Agreement from day 1. Don't wait until the end to realize your data is inconsistent. Have at least 10% of your data labeled by 2 different people and compare them. If they don't agree, stop and figure out why.
And step 4. Use model-assisted labeling as soon as your model is even slightly useful. Don't have humans draw boxes from scratch if the AI can get it 80% right. Have the humans be the editors, not the writers.
It is the human-in-the-loop philosophy. The human is there to provide the nuance and the final check, while the machine does the grunt work. In 26, the most successful AI companies aren't the ones with the most GPUs, they are the ones with the most efficient, highest quality data pipelines.
It is funny, isn't it? We spent decades trying to build machines that think like humans, and it turns out the secret was just hiring millions of humans to tell the machines what to think.
It is a bit of a paradox, but it is also a huge opportunity. If you can master the data kitchen, as we have called it, you can build models that are safer, more accurate, and more useful. And honestly, the tools have never been better. Whether you are using the free, open source stuff or the high-end enterprise platforms, you have the power to create ground truth.
Ground truth. It sounds so definitive, but as we have seen, it is a very human, very messy process. I think that is a good place to wrap up the main dive. Herman, any final thoughts on where this goes? Are we ever going to reach peak labeling?
I don't think so. As AI gets smarter, we will just move on to labeling more complex things. We went from, is this a cat, to, is this medical advice safe, to, is this code efficient and secure? The frontier of human feedback just keeps moving further out. We might even see a day where we are labeling the emotional intelligence or wisdom of a system. How do you draw a bounding box around empathy?
That sounds like a nightmare for the Cohen's Kappa score. Imagine trying to get consensus on whether a robot is being empathetic enough.
The more subjective the task, the harder the annotation. But that's where the value is. The things that are easy to label are already solved. The future of AI is in the things that are hard for humans to agree on.
We are the eternal teachers, and the AI is the student that never graduates.
Precisely. Well, let's look at the actual takeaways here. If you're listening and you're in the middle of a project, my biggest piece of advice is to audit your current labels. Go back and look at a random sample of 100 labels from last month. I bet you will find a 5 to 10% error rate. Fixing those errors will do more for your model than doubling your training time.
And don't sleep on the open source tools. Label Studio is incredibly powerful and can save you a fortune while keeping your data under your own control. It is a great way to pilot your workflow before you commit to a big enterprise contract.
And finally, keep an eye on synthetic data. If you are in a field like robotics or autonomous systems, where real data is expensive or dangerous to collect, synthetic data is your best friend. Just make sure you have a human-labeled test set to keep the synthetic data honest.
Well, this has been a deep dive into the world of boxes, tags, and human feedback. Thanks to Daniel for the prompt. It is a topic that doesn't get enough sunlight, but literally powers everything we do in AI.
It really does. It is the foundation. If the foundation is shaky, the whole building falls down.
Thanks as always to our producer Hilbert Flumingtop for keeping us on track and making sure we don't wander off into too many tangents about statistics fraternities.
And a big thanks to Modal for providing the GPU credits that power this show. They make it possible for us to explore these technical depths every week.
This has been My Weird Prompts. If you are enjoying the show, a quick review on your podcast app helps us reach new listeners and keeps the brotherly banter going.
You can also find us at myweirdprompts.com for the RSS feed and all the ways to subscribe. We are everywhere you listen to podcasts.
All right, Herman. I am off to go label some of my own data. Mostly, is this snack healthy or is this snack delicious?
I think I know which way those labels are going to lean. Corn.
You know me too well. See you next time, everyone.
Goodbye.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the close from sloth